Do you think we can get 20 marks in less than 3 minutes in chemistry? Let me start the timer. Let's find out how we fare on these PYQs. First question. Okay, you've got a lot of gases and you've got to figure out the electronic configuration. Sulfur is also around. Nitrogen, P3. Mark this, move on. That's it. You've got to be able to read questions quickly, identify what is the main thing and move on. This is one of those questions. Next one also is something like that. Electronic configuration of Einsteinium. Who knows what that is? Of course, it's named after Einstein. 99. Okay. Radon, 86 plus 13. That gives you this. Okay, 13 split to 11 plus 2. Why am I doing this? Because you've got 7s2 in all of these. That's common. So only one that makes sense is option C. There you go. 2 questions in less than 30 seconds. Which of these gives you positive? This is a slightly tough question. Iodoform test, right? Okay, iodoform, you didn't have a methyl group, alpha to a keto group or a secondary alcohol. So I'm going to mark out the ones that are not going to fit the bill. Between B and C, if you're confident, follow up, or else it's completely fine to skip this question. How would I solve this? Aqueous KOH would give me a diol, and then we've got to remove water. I know this is a bit of a tricky step. Next step is straightforward, right? Add KOI. There you go. That's the awesome yellow iodoform, and hence that should be the answer. Skippable, but also doable. Okay, 2 statements. High oxidation states are more stable down the group among transition elements, unlike p block elements. Interesting. Copper cannot liberate hydrogen from weak acid. This one's completely true. This first one, you either know it or you don't. How do you know it? If you've been solving exemplar questions. You've got 2 questions, 54 and 63 in exemplar, that tell you that osmonium has a state of +8. Okay, definitely higher than anything in the earlier series. Hence, both of these statements are true. And you're like, hey, we're picking easy question. That's the focus of test taking, doing easy questions quickly. Last one, we already had the last one less than 2 minutes out, right? Which of the following is a correct equation to show change in molar conductivity with respect to concentration for a weak electrolyte? That's the keyword right here. Weak electrolyte. Strong electrolyte has a root C thing, so that's not our focus. So let's cross it out. Okay, so we've got to figure out between B and D. But what's common between B and D? Okay, all of this, a lot of lambda not M squares, lambda not M not squares, and C and K. If I identify which side of the equation these guys lie, just these 2 terms, I can figure out the answer. What do I mean? You have to, use mathematical tools in cases like this. Alpha is lambda M by lambda not M. Okay, I set up this in my head. Maybe you've already solved this as well, but Ka is going to be C alpha square by 1 minus alpha. Substitute things and you get this awesome expression. Clearly, if you take things to the other side, this goes here, this stays here, you get that lambda naught M whole square times Ka into something is going to be equal to C lambda M square, and that is all you need. Look at this, these 2 are on opposite sides, hence D is the answer. Boom, less than 3 minutes we figured this out.